Welcome friends. Let us see some definitions of infinite series. An infinite series, as the name itself tells, is a series of infinite number of terms. That is, suppose u1, u2, u3, so on is a sequence of real numbers, then summation n taking the value from 1 to infinity of un, that is u1 plus u2 plus u3 so on up till un plus so on continued up to infinite terms is called an infinite series. Here un denotes the nth term or the general term of the infinite series. Now let us see the convergence, divergence and oscillatory nature of a infinite series. An infinite series is said to be convergent if limit as n tends to infinity of Sn is equal to L. Here Sn denotes the sum to n terms of the series. If you take the first n terms u1 plus u2 so on up till un, that is denoted by Sn. Now when you take the limit as n tends to infinity of this Sn, if it gives you a finite value, then the series is said to be a convergent series. Now suppose this limit, that is limit as n tends to infinity of Sn, is plus or minus infinity, then the series is said to be a divergent series. If this limit gives two or more values, that is limit as n tends to infinity of Sn, if it gives two or more values, then the series is said to be a oscillatory series. Now, a necessary condition for convergence. If we have a positive term series, summation un as convergent, then limit as n tends to infinity of un is 0. That is, a positive term series here denotes a series of positive terms. Or if at all there are some negative terms in the series, they are neglected and we consider only the positive terms. Now, for such a positive terms, whenever you have summation un is convergent, then limit as n tends to infinity of the nth term will be equal to 0. Now thus we can also say that if limit as n tends to infinity of un is not equal to 0, then summation un will be a divergent series.